In correlation chapter, we have discussed already two methods of measuring correlation. The very first we have discussed scatter diagram methods, and second we have discussed graphical methods of correlation. In today's video, we will discuss a very important methods of correlation that is so important, and so many times the questions from this method in the examination is over there. That method is called the Pearson coefficient method. It's the best one and ideal methods of correlation. So today we will having one or two questions in this video for related to the Pearson coefficient of correlation method is over there. So the very first we see the direct method of measuring correlation. So the direct method for that correlation, R is the symbol of correlation, that is sigma dx dy upon n multiplies standardization x multiplies standardization y. So with the help of this we can calculate the Pearson correlation is over there. Here the dx is equal to x minus x bar and dy is equal to y minus y bar. Standard deviation x for calculating, that is sigma d square x divided by n. Standard deviation y, that is sigma d square y divided by n. So this is the direct methods of correlation. For measuring the correlation, the very first we will calculate the standard deviation of x series, standard deviation of y series, then putting the all value in this, that is sigma dx dy upon n divided by sigma dx divided by n standard deviation x and standard deviation y is over there. If we are keeping the value here, R is equal to sigma dx dy. So the first formula for the correlation may be this, divided by n multiply by sigma d square x upon n sigma d square y upon n. So we can write here sigma dx dy upon n under root sigma d square x sigma d square y, but divided by n because 2 times root n is out and n to n cross. So another one formula for sigma dx dy upon sigma d square x guna sigma d square y. That may be also a important formula for calculating Pearson coefficient is over there. So this is R is equal to sigma dx dy divided by sigma d square x sigma d square y. This is also very important formula for calculating correlation. So the very first, this is the second form of this. So we can say the R is equal to sigma dx dy upon n guna standardization x guna standardization y, or R is equal to sigma dx dy upon sigma d square x guna sigma d square y. Both are the direct methods for calculating correlation is over there. Step deviation method, assume mean method. If assume mean method is to use, then R is equal to n guna sigma dx dy minus sigma dx guna sigma dy upon n guna sigma d square x minus sigma dx raised to power 2 under root n guna sigma d square y minus sigma dy raised to power 2. It's very important. Here dx is equal to x minus assume mean x and dy is equal to y series minus assume mean of y. So in case we are getting numbers, suppose we are getting x bar or y bar in odd numbers, no problem at all, we can use the direct formula. But if our arithmetic mean of x and arithmetic mean y are in points, then we can having a assume mean method. Assume mean method, it means similarly as we have gone through in previous measurement of the standard deviation, we have assume mean method also. So similarly, in correlation also we are having assume mean methods. In that we will assume the one as arithmetic mean of X series and is 1 point as arithmetic mean of Y series. Putting the value, we can having this formula. We are having so many formulas for calculating correlation, but this is the best formula set. That's why I have selected here. So you should remember only for one that formula. This method for the direct method, and this method for the assume method. One more method is n guna sigma xy minus sigma x sigma y divided by n guna sigma x square minus sigma x raised to power 2 n guna sigma y square minus sigma y raised to power 2. It is also a important formula. You can get value of correlation with any of the formula which you may like. This is direct method, this is assume method, and in this method you do not want to do, just you have to keeping the x value x square, y value y square, and xy. Directly you can calculate with the help of this method. You can calculate the value of r. So the value of r will be same. Either you are using this formula, that is related to the direct method. Maybe you are using assume methods, or maybe using direct. Another one formula that is also important. So today in this video we will having a question. Firstly, I will solve this question with the help of this formula that is called direct formula. Secondly, the same questions we will do with the assume method also and this method also. So you may be learn the comparison between all three methods, and then you may select which formula I should select for my measuring the correlation is over there, because the result will be same. So doesn't matter which formula do you like. So I am having one question, and we will discuss this question with all three formula. So you may be having a knowledge the difference between all of them. So I am having the formula. I am having a question. Very first I am having the question. Calculate the Pearson coefficient of correlation from the following data. Age of husband is given. This may be the X series, age of husband, that is 23, 27, 28, 28, 29, 30, 31, 33, 35, 36. Age of wife is also given. Maybe it is Y series, 18, 20, 22, 27, 29, 27, then 29, 18, 20, 22, 27, 21, 29, 27, 29, 28, and 29. So in this question, we have given the age of husband and age of wife. We are to calculate the correlation between both of them. So this is our X series and this is our Y series. So I am writing here X series, that is 23, 27, 28, againly 28, 29, 30, 31, 33, 35, and 36. So getting dx, d square x, y series is 18, 20, 22, 27, 21, 29, 27, 29, 28, 29. So 10 age of husband is given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 age of their wife is also given 1, 2, 3, 4, 5, 6, 7, 8, 9 or 10. Then we have to calculate dy, d square y and dx dy. So the very first we will add this. Firstly, we are using direct method. For that, 23 plus 27 plus 28 plus 28 plus 29 plus 30 plus 31 plus 33 plus 35 plus 36. We are having 300. So the x bar is equal to sigma x divided by n, that is 300 divided by 10, that is 30. So deviation from 30, 23 minus 30 minus 7, 27 minus 30 minus 3, then minus 2, 28 minus 30 minus 2, 29 minus 1, 0 plus 1, 33 minus 30 plus 3, 35 minus 30 plus 5, 36 minus 6. Because dx is equal to x minus x bar. So 23 minus 30 minus 7, 27 minus 30 minus 3, 28 minus 30 minus 2, 28 minus againly 49, 9, 4, 4, 1, 0, 1, 9, 25 and 36. So addition of this will, again we add this, that is 250. 18 plus 20 plus 22 plus 27 plus 21 plus 29 plus 27 plus 28 plus 29 plus 29, 250. So the value of second is 250. Againly I am adding 18 plus 20 plus 22 plus 27 plus 21 plus 29 plus 27 plus 29 plus 28 plus 29. 250 is okay. So the y bar is equal to sigma y divided by n, that is 250 divided by 10, that is 25. So dy is equal to y minus y bar. So the very first 18 minus 25, that is minus 7, 20 minus 25 minus 5, minus 3, 27 minus 25 plus 2, minus 4 plus 4 plus 2, 29 plus 4, 28 plus 3, 29 plus 4. So addition, this is 49, 25, 9, 2 2 ja 4, then square of 4, square of 4, square of 2, square of 4, square of 3, square of 6, 4. So the addition of this d square x and d square y. So first 49 plus 9 plus 9 plus 10 plus 25 plus 36, 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. First is 49 plus 3 3 is 9. Okay. Then addition 9, then 1, then 9, then 25, then 36. So this is 138. Now the addition of d square y we require, that is 49 plus 25 plus 9 plus 4 plus 16 plus 16 plus 4 plus 16 plus 9 plus 16, that is 164. Next we require dx and dy. 7 7 ja 49 plus 3 5 ja 15 plus value, 2 3 ja 6 plus value, 2 2 ja 4 minus value, 1 4 plus value, 0 multiply 4 that is 0, 1 multiply 2 that is plus 2, 3 multiply 4 that is plus 12, 5 multiply 3 that is 15, and 6 multiply 4 that is 24. So that is 127 minus 4 that is 123. So this will be 123. So what we are doing, we are using here direct method for calculating correlation, coefficient of correlation. Coefficient of correlation direct method, that is sigma dx dy upon sigma d square x guna sigma d square y. The formula for that is, so the value of correlation is 123 divided sigma d square is 138, 164. So it's very easy. 138 multiply 164 divide 150.43. 123 divided 150.43. So the value of R is 123 divided this value, that is 0.817. So we will say 817. So we will say it's a higher degree positive correlation. Higher degree positive correlation between age of husband and age of wife. So this is the first methods to calculating correlation value. We have used this formula. So the very first x, we are to calculate dx, d square x, y, dy, d square y, and dx, dy. No problem at all. Very easily you can calculate. Another one direct method is also available. That the very first we have calculated standard deviation of x. Standard deviation of x, that is sigma d square x upon n. Here the sigma d square is 138. So we will 138 divided by 10 is equal to 13.8. So the value of sigma dx, that is 13.8 under root 3.7148. So standard deviation x, that is 3.7148. Similarly, standard deviation y is equal to sigma d square y divided by n, that is 164 divided by 10, that is 16.4. So 16.4 under root 4.0496. Standard deviation 4, that is 4.0496. R is equal to sigma dx dy upon n guna standard deviation x guna standard deviation y. That will be the formula. So R is equal to 123 10 multiply 3.7148 multiply 4.0496 0.812 817. Already we have calculated. The similar value will become 0.817. So this is the direct methods of calculating Pearson coefficient. The same question we can help with the indirect method also. So this is direct method. Againly we are having same question with indirect method, assuming method, this is called. So we are having x value, y value. Now dx, d square x, dy, d square y, dx, dy. Here suppose our assumed mean of x is 28. Assumed mean of y is, suppose that is 29, because 29 one time, two time, three time available. Any of the point you can having the assume. So I assume 28 is arithmetic mean and 29 is arithmetic mean in y series. So 23 minus 28, that is minus 5. 27 minus 28, that is minus 1. 28 minus 28, 0. 28 minus 28, 0. 29 minus 28, 1. Here 2, here 3, here 5, here 7, here 8. So this is 5 plus 6 and 5 plus 6, 5, 7, 12, it is 20. Square of this, d square x, 25, 1, 0, 0, 1, 4, 9, 25, 49, 64. So addition of this is 25 plus 1 plus 1 plus 4 plus 9 plus 25 plus 49 plus 64. 25. Firstly 25 plus 1 plus 1 plus 4 plus 9 plus 25 plus 49 plus 64. So that is 178. Now dy, assume mean is equal to 29. So dy, that is y minus assume mean of y. This is x minus assume mean of x. So 29 we have assumed. So 29 minus 18 minus 29, that is minus 11, minus 9, 22 minus 29, that is minus 7, minus 2, minus 8, 0, minus 2, again 0, minus 1, again 0. So these values are 20 minus plus 9 plus 8 plus 2 plus 1 minus 40. D square y 121, 81, 49, 4, 8 8 are 64, 0, 4, 0, 1 and 0. $324. And last value we have to calculate dx dy. So dx dy, 5 multiply 11, that is 55. 9 multiply 1, that is 9. 7 multiply 0, 2 multiply 0, 8 multiply minus 8, 0 multiply 2, 2 multiply minus 6, 0, minus 7, 0. So that is 55 plus 9 minus 8 minus 6 minus 7, that is 43. So R is equal to n guna sigma dx dy. Formula minus sigma dx guna sigma dy divided by first under root n guna sigma d square x minus sigma dx raised to power 2 in second under root n guna sigma d square minus sigma dy raised to power 2. So this is the formula for the assuming methods of Karl Pearson coefficient. N multiply sigma dx dy minus sigma dx guna sigma dy divided by in first under root n guna sigma d square x minus sigma dx raised to power 2 and in second under root n guna sigma d square y minus sigma dy raised to power 2. So value of n is 10 multiply 43 minus the value of sigma dx is 20, value of sigma y is minus 40 divided by in first root 10 multiply 178 minus 20 raised to power 2, 10 multiply 324 minus 40 raised to power 2. So that is 430 plus 800 divided by 1780 minus 400. 3240 minus 1600. So 1230 divided by 138, and this will be 1640. So if you will calculate, you will get 0.817. So this is assume-in method, and the help of this assume-in method also we are getting the same. There is a high degree positive correlation. It means you can use any one of the formula, no problem at all. The result will be same. Either you are using direct formula or either you are using assume-in method also. The result will be same. So no problem at all. Which method you may like? If you are feeling that this method is easy because in this method we have assumed arithmetic mean, that is 28. In this we have assumed the arithmetic mean is 29, and by assuming of arithmetic means we have calculated the value is same. Already we have calculated that with the direct method also we have get the result, that is 0.817, and in this method is also we have got the result same. Here you will say in direct method we are having 123 divided under root 138 under root 164. Here 0 is excess, in both 0 is excess, so the result will be same. Okay. In direct method, if we calculate value of x bar is equal to assume mean plus sigma dx upon n. So assume mean is 28 plus 20 upon 10, 28 plus 2, here 30. Already we are having in this. Y bar, that is assume mean plus sigma dy divided by n. Assume mean was 29 minus 40 upon 10, that is 29 minus 4, that was 25. So the arithmetic mean previously was 30, here also 30. Y bar is 25, here also 25 is out there. So these, the same question we have discussed with the help of first one, that is direct method, and second one, that is assume-in method. The result is same from both of the methods. So you may be having any of the method you can use for that, getting the Pearson coefficient of correlation is over there. Another one method is also available, that is x square, y square and xy required. So here n r is equal to n guna sigma xy minus sigma x sigma y upon n guna sigma x square minus sigma x raised to power 2 in first under root, and n guna sigma y square minus sigma y raised to power 2 in second under root. In that series, this is x series and this is y series. So the very first addition of x series is 300, addition of y is 250, already we have calculated. Now x square required 23 multiplied 23, that is 529. 27 multiplied 27, that is 729. 28 multiplied 28, that is 784. Again 784. 29 multiplied 29, that is 841. 30 multiplied 30, that is 900. What I am doing? Getting x square. 31 multiplied 31, that is 961. 33 multiplied 33, that is 1089. 35 multiplied 35, that is 1225. And last one 36 multiplied 36, that is 1296. And addition of this is 9138. Now we got y square. Y square is 18 multiplied 18, that is 324. 20 multiplied 20, that is 400. 22 multiplied 22, 484. 27 multiplied 27, that is 729. 21 multiplied 21, that is 441. Then 29 multiplied 29, 841 here, 8 4 1 here also, and last 8 4 1 here also. 27 multiply 27, 729, and 28 multiply 28, that is 784. So the result will be 6414. Next we require value of xy, that is 23 multiply by 18, that is 414. 27 multiply 20, that is 540. 28 multiply 22, that is 616. 28 multiply 27, that is 756. 29 multiply 21, that is 609. 30 multiply 29, that is 870. 33 multiply 29, that is 5957. Some mistake is over there. Again we have to calculate this. Some mistake may be over there. Okay. 23 multiply by 18, 414. 27 multiply 20. 27 multiply 20, that is 540. 28 multiply 22, that is 616. 28 multiply 27, that is 756. 29 multiply 21, 609. 30 multiply 29, 870. 31 multiply 27, 837. 33 multiply 29, 957. 35 multiply 28, 980. 36 multiply 29, 1044. So the addition of this is 7623. So in putting this value in formula, 10 multiply sigma dx dy 7623 minus sigma x is 300, sigma y is 250, divided by in first under root 10 multiply 9138 minus 300 raised to power 2, and this 10 multiply 6414 minus 250 multiply square. So the value of R 76230, 75000. One three eight zero. 1380. One 640. Again we are getting the same result here. 1230 divided by 1380 and 1640. Already we have got these numbers in with the assuming method also. So the result will be same 0.817. So this method may be also applied by you. In this method you do not want any kind of the deviation is over there. You are having x, you are having value y. Firstly getting the square of x, that is x square, getting the square of y, that is y square, and multiply x and y, we are getting this result. Then we will use that formula R is equal to n गुणा sigma xy minus sigma x multiplied by sigma y divided by n गुणा sigma x square minus sigma x raised to power 2, and in other n गुणा sigma y square minus sigma y raised to power 2. By the putting of value of this 10 multiplied 7623 minus 300 multiplied 250, then putting the value, again we are getting the same result is over there. So we have done a same question with the direct method, with the assuming method, and this wonder method also we have used. So this is also a easiest method if you are having the calculator allow in your examination, no problem at all. The result will be same 0.816. There is a higher degree positive correlation. So which method you may like that is this is easy for me, you can select that method, no problem at all. We will later in next video we will discuss these methods in againly. Thank you. I think this video will be having helpful to know how to calculate Pearson coefficient of a scheme correlation in this. Thank you.